In this video, I just want to give you a little bit of introduction to the Cso tool, which is really just an extension of the RL tool that we already started using in this class. So Cso tool is just called in the same way that we call the RL tool, where we put in the first argument, we put the system plant, the open loop plant, and then we put in the controller. And again, here I'm just going to put in proportional control, and I'll add additional controller terms once I open up the tool. So you hit enter, and it pulls up something that looks like this. Similarly, you can kind of dismiss some of the side and top toolbars just to maximize your viewing area. And so one of the things you'll realize is that the big difference is the fact that you have the root locus and the step, but then you also have the Bode diagrams. And so one of the really convenient things about this setup for the Bode diagrams is it automatically tells you what your gain margin is. That's GM, gain margin, which happens at this frequency, and the phase margin, which happens to correspond at this frequency here. And so right now it's automatically telling you that it's unstable. And so if you want to, you can kind of take a look at that and realize that, yes, the gain margin is above, the gain is above the 0 dB line when this crosses 180. So that kind of indicates already that it's unstable. You can also see it unstable by the negative phase margin. You can also come over here to the root locus and observe that we have two poles, closed loop poles, that are now in the right half plane. And so that means that the system's unstable. And again, you can take a look at this step response and observe that you've got this wild oscillation and this 10 to the 13, which is kind of indicating that things are diverging. All right, so that's not great. We can adjust this by grabbing these poles here, just like we did before, and pulling them back into the stable region. So now it's stable. Now you can observe that it's saying stable loop and that you've got a positive gain margin and a positive phase margin. One of the cool things is we know that proportional control, just changing these gains, so the location along the existing root locus, shifts the Bode diagram up and down. And so they've already implemented that in here. So I can grab this magnitude plot and I can shift this up and down directly if I wanted to manipulate that. And notice what's happening is that in the right plots, that things are updating, and that, for example, you see that the pink dots are moving along the root locus as I'm changing the gain, which is happening because I'm sliding this Bode magnitude plot up and down. And what you're also observing is this crossover point where you hit the 0 dB line. That's where we measure our phase margin, and so that phase margin is being measured, and as I move this around, I'm kind of actively moving that point. And so that can be a nice, really visual way of understanding and being able to just see the phase margin updating. So here we'd like to also be able to add more sophisticated compensators and controllers. So if I hit right click and edit compensator, I can pull up this window, which is something we've seen before. And I can go ahead and add. And so just for the sake of demonstration, let me add a lead compensator. So nominally these are going to be at -1 for the 0 and -10 for the pole. And so in this case, what you see is that you get your pole and 0 like we already saw in the root locus, but you also get them noted in the Bode diagrams. And so the location of these happen at the frequency. So this is 10 and this is at 1, and so that's why these two are located here. And one of the really nice features of the Cso tool is also that you can grab, just like you can grab the red X and red circle over here, you can do that here, and I can move that pole around and I can automatically update everything. And one of the benefits here is the fact that the Cso tool with this interactive Bode diagram gives the ability to really see the loop shaping process happen. And so again, you should go back and refamiliarize yourself, for example, in this case with the lead compensator magnitude profile and the phase profile. And so one of the characteristics about the lead compensator is the fact that it adds phase, but it adds phase in between this 0 and this pole. And so if I make that closer, or I make it farther apart, the region that receives more phase it gets bigger because it's everything, all the frequencies between this 0 and this pole. And so, for example, if I wanted to add some more phase in order to pull this up, I could grab this and move this to the right, and you can kind of visualize the idea of being able to shift that by adding the extra phase here. Likewise, you can kind of think about how the different pole and zero affect the overall magnitude diagram as well. And so what you should do is you should have those fundamental shapes of, for example, in this case, the lead compensator in your mind, and understand as you move these pole and zero around that you're directly shaping these Bode plots. But that's not to say that you have to leave everything that we had behind in terms of the root locus and the step response. So those are still really great tools, but now this allows you to do a little bit more of the loop shaping directly. And so remember that the crossover frequency, where the 0 dB line is, where it crosses the 0 dB line, that magnitude, that is our crossover frequency, and that is exactly this frequency that you have right here that is where we measure the phase margin. So this right here is the crossover frequency that we're going to use as a proxy for closed loop bandwidth. So that's something to keep your eye on, as well as these other terms for gain margin and phase margin.